This is lesson 7.1 in intermediate algebra. And so listen to me talk for a few minutes here as we get started in a brand new class. This is not a continuation of elementary algebra. This is a new course which is called intermediate algebra. Same book, chapter 7. And chapter 7 is a review of the first 6 chapters. So we are going to be doing a lot of things, most things that you've already done, but I suggest that you not just flippantly look at this chapter and just kind of whiz through it, that you take time to review and remind yourself on how to do a lot of these problems here when we get started. So let's get started with 7.1. And I would highly suggest that you take good notes for this particular chapter, because there's a lot of definitions and a lot of properties here that you're going to need to have in your notes that are in the boxes throughout the chapter. Alright, so example 1. We have 3 different equations that they give us. 2x minus 5 equals 9. They also give us x minus 1 equals 6, as well as x equals 7. So we have 3 different equations there, and remember, an equation has an equal sign, so that's what makes it an equation. And these are called equivalent equations simply because the answer to each of these equations, that's a 6, not a b, is 7. If we put a 7 in here, we get 14 minus 5 is 9. We put a 7 in there, 7 minus 1 is 6. And obviously, put a 7 there, and we get 7 equals 7. So they're equivalent equations because the number that makes each one a true statement is the same number. Alright, so let's jump to example 2. And it says, find the solution set for 3a minus 5 equals negative 6a plus 1. Okay, so what you're going to find here, and enjoy that these equations are going to be pretty simple. They will get a lot more challenging as the course goes on. I guarantee it. In this course, it moves rather quickly. So enjoy chapter 7, having a bunch of review problems, because it will get a little bit tougher. Alright, so if you remember, in order to solve for the variable a, we need to get all of the a's on one side of the equal sign and all of the numbers on the other side so that we can determine what a is. So first thing I would do is move your a's over to the same side by adding a, or the 6a, to both sides. And then getting rid of your numbers. And we get 9a equals 6. And then we get rid of our 9 by dividing each side by 9. And we get a equals 6/9, or that reduces to 2/3. So your a ends up being 2/3. That is your solution set. Now when you take 2/3 and put it back in your original equation, you should get a true statement. Okay, so let's look at example number 3, and it says solve each equation. Okay, this case it doesn't look too bad. Negative x equals 4, but we're not looking for negative x, we're looking to find out what x is. So there is a method in order to solve this. It's just really easy just to give you a rule to follow. If you want to change this x here to its opposite, if you want to change it to a positive x, you change the sign of everything in the equation and you're okay. Okay? So if I had negative x plus 2x minus 6 equals 4, I can change this negative right here to positive if I change the sign of everything else. Okay, that equals the same thing, but we're able to change the sign to its opposite. Okay, and the reason we can do that is I just say I'm going to multiply this whole thing by negative 1. And when I do that, that changes that to a positive, and a negative. Okay, so that's the reason we can do that, but it just seems kind of silly to go through all that work of doing that when we can just change the sign of everything and we're good to go. Alright, so if we have something like 2/3 x plus 1/2 equals -3/8. Okay, when we're dealing with fractions, and this is very important, the and here, we have an equal sign. If we look for the common denominator of 3, 2, and 8, okay, it's not 6, even though 3 goes into 6 and 2 goes into 6, 8 doesn't. It's not 8 because 2 goes into 8 and 8 goes into 8, but 3 doesn't. So we have to keep going until we find a number that all three of these numbers go into, and in this case it's 24. If we multiply the entire thing by 24, then we can get rid of all the fractions. So we have 24 times 2/3 x plus 24 times 1/2 equals 24 times -3/8. Alright, so when we do this, we can cancel that and get a 1 and that and get an 8. 8 times 2 is 16. Same thing here. 24 over 2 is 12. And cancel that and give me a 3. 3 times -3 is -9. Now, notice what we have there. We have no fractions. So now I can subtract 12, and I get 16x equals -21. Divide by 16, divide by 16, and I get x equals -21 over 16 for my answer. And that will not reduce, so I am done there. Same kind of thing can be done when you're dealing with decimals. So, again, this is review. If we have 0.06x plus 0.05, and we are multiplying that by 10,000 minus x equals 560. Okay, so what we've got here is we've got a bunch of decimals here. Alright, so this is what I suggest doing. If we can distribute, you always distribute first. So we're going to multiply that times that, and then this times this. Okay, so we just distributed. Then I look and see which of my decimals that I have left have numbers the furthest away from the decimal sign. Okay, this one has a number here, the 6, 2 digits away from the decimal, and this one has 2 digits away. Okay, so they're both the same distance, but normally what you do is you look at the one that is the furthest away, and you multiply the entire thing by that many zeros. So notice this is 2 decimals away. So we're going to multiply the whole thing by a number with 2 decimals, or 2 zeros, which is 100. And then we distribute that 100. So we end up getting 6 plus minus equals 56,000. So we just multiplied the 100 times everything there, which basically means we moved the decimal place over 2. So here we moved it over 2 and got 6. Here we moved it over 2 more, so we added 2 zeros to that. Here we moved it over 2. Here we added 2 zeros to that. Okay? Alright, so now we're going to take our 6x and our 5x and get 1x. Now we're going to subtract 50,000 from both sides. and we get x equals, okay, 6,000. Now students say, well, yeah, we did that, so now do we have to convert it back to a decimal? No, you are done. You don't convert, you don't do anything else. That is the end of the story right there. Alright, let's move on to example number 6. Solve the equation 8 minus 3 times 4x minus 2 plus 5x equals 35. Again, like I said, first thing you want to do is distribute it. Okay, so we just distributed. And we're going to get all the variable terms on one side and all the constant terms on the other. So we're going to combine what we have there. Okay, and those are done. We're going to add these. Okay, now we're trying to isolate the variable, get it all by itself. So I'm going to subtract 14. 35 minus 14, 21. Going to divide by negative 7. And x equals 21 over 7, which is 3. And because of that negative, we get a negative 3. And that's it. Alright, so next video we're going to just continue on with this lesson.